Alright guys, so on Friday we went ahead and covered graphing quadratics in Vertex Form. So I wanted to do a recap on that as that's pretty much where we left off. And as you could see, I've attached the filled out version of this as well as these notes. And I'll add another video just so that you guys can get another perspective on graphing in Vertex Form. But before we begin, I'd just like to quickly say, I know things are pretty interesting right now, to say the least, but overall, I know that we have all the technology and resources to be able to be successful in this online distance learning. So with that said, I miss you all, and let's get started. So this first example says graph each quadratic equation. Okay, so what we have to remember is that there's a form here. So this form is y equals a times x minus h squared plus k, where your vertex is at h comma k. And so it's basically the opposite of whatever h is, and k stays the same. Okay, so just remember opposite, same. And I'll put that up here. Opposite, same. All right, so when we go to graph the quadratic equation, we know that the vertex is at the opposite of our -1. So if we see the opposite of h, this is our h right here. The opposite of a -1 is a +1, so I put that in parentheses. And then we see that k is going to stay the same. So whatever the k value is, it stays the same, and it becomes the y value in your vertex. So now you have a vertex at 1, 2. So you want to first go ahead and begin by graphing that. So 1, 2, right here. Now the axis of symmetry is your AOS is at x equals whatever the value of h is. And so since we said h is a +1, excuse me, here, that means x equals a +1. So then the next thing I'd like you to do is go ahead and graph that. And now, because there's no negative here, your a value is positive. So with that, I know my graph is going to open upward. So I'm just going to go upward with my line of symmetry. So that was the second thing that we did. The third thing is to understand, does our parabola open upward or downward? So if a is positive, our parabola opens upward. So if a is positive, our parabola is happy, it opens upward. And in this instance, since there's no negative, you know it's positive, and our parabola opens upward, which means that it has a minimum point, the lowest part of the parabola. So we'll circle minimum. But at the same time, you can answer that after you graph, just to view that it is a minimum. All right, so now we're going to go ahead and graph our a value. Now, to graph the fourth, this is really actually could be non-essential right now. So step 3 is going to be to graph a. So the way we do that is we're going to say whatever a is and put it over 1, meaning this is going to be our rise, and this will be our run. Now with parabolas, graphing a, it will always be 1 unit, always. Your run, you'll only run 1 unit, first off. Secondly, let's see here. Well, let's just go ahead and start with that. So when we graph, secondly, that's what it was, sorry. It is not constant like a linear function is. You can't keep rising and running, but this does work one time from the vertex. So one time from the vertex, if a is 1, so you see here how there's an imaginary 1 here. So if a is 1, we're going to do this. A is 1, and then we're going to run 1 always. So we run 1, up 1. We run 1, up 1. Okay, and then you can obviously use a line of symmetry to get the other side. So that only works 1 time. So that's step 3. Step 4, you need to really find another point, because I want you guys to try and get 5 points when possible. So in this case, I'm looking at my x-axis and I notice that I don't have a value at -1 or f of 1, 2, 3, f of 3. So I don't know what f of -1 is or f of 3, meaning when x is -1, what is y? Or when x is 3, what is y? So that's what I'm going to go find out. And the reason why I chose those 2 points is because if I zoom in here, the point to the left and the point to the right are those values at x. And so that's going to help me keep my numbers small and hopefully fit on the grid by just picking an x value just to the right of this point and to the left of this point. All right, so I can pick either point, and I want to pick the point that's going to be easiest for me. So in this case, I like to pick positive numbers. So this is 1, 2, 3. So I'm going to test f at 3. What is y? So the way I'm going to do that is I'm going to plug into the original equation. Wherever I see an x, I'm going to plug in a 3. So in the original equation, I'll use a space, y equals 3, I think it's -1 squared plus 2. Let me go back and check. -1 plus 2, that is correct. Okay, so now we're going to simplify the next step. So 3 minus 1 is 2, and we're going to square that, plus 2. 2 squared is 4 plus 2, so we get a y value at 6. So when x is 3, y is 6. So here's 1, 2, 3, up 1, 2, 3, 4, 5, 6. Now, the interesting part about the line of symmetry is that instead of going and plugging in f at -1, I know what it is because I can use this point as a symmetrical value. So if I go in 2, I go out 2, and I know I have another point there. So to take out all that, to count in 2 to the line of symmetry, count 2 out, and now you have points that are symmetrical. At this time, you have finally completed graphing a quadratic function. So I'm going to pause it right here only because the upload time for this one video is going to take me about 20 minutes, but for you guys it will be less than 7, I guess. So stay posted, and I'm going to add another video to show you guys what I'm doing.